My name is Engin Zeydan. I am the project coordinator of UNITY-6G project from CTTC. UNITY-6G project is abbreviation for Unified Architecture for Open RAN Enabled Distributed Scalable and Sustainability Enhanced 6G Networks. What we want to aim is to unify the enablers technologies under the 6G umbrella in this project. If you look at the project in a nutshell, UNITY-6G is aiming to have a sustainable, scalable, intelligent, and more integrated 6G networks. As you can see from this map, we have around 20 partners all around Europe from 11 countries. And partners are including 7 large organizations, 7 research and research technology organizations, and 6 SMEs. In addition to me, as project coordinator, we have Dr. Luis Miguel Contreras from Telefónica acting as a technical manager. The project has started this January, and it will going to continue for 3 years until the end of 2027. Total effort is more than 1,000 PMs, and the total budget of the project is 10 million, with EC contribution around 8 million, and Swiss partners contribution is around 1.5 million euros. This is just a brief introduction of the architecture that we are aiming in UNITY-6G. I will not go too much detail, but just to give you an idea of the layers, we have management and orchestration layer. Underneath we have edge cloud continuum layer, and in the bottom we have infrastructure layer. And then including all these layers, we have a digital twin layer, which I will describe next. In the infrastructure layer, we have 2 verticals. One vertical is related to renewable energy source, smart grid integration into the network. And then another vertical is related to extended reality, which we also aim to integrate this XR streaming application into the 6G. And when we look at the technologies that we are aiming, so the system is actually architecture is trying to integrate terrestrial networks, which includes open radio access networks and also non-public networks with the non-terrestrial networks. So this is one of the main aim of the UNITY-6G to integrate all these diverse technologies under the umbrella of 6G. On top of it, we have enhancements in the transport network over the enhanced xHaul. We will work on time-sensitive networking domain in the transport network side. When we look at the upper edge cloud continuum, we will have a network core, which we will try to expose the functionalities of this, let's say, integrated architecture to the applications, and also possibly to the Stream C and the projects. And when we go up, we see different applications which are related to green load balancer and semantic aware edge controller. So the aim is to have extend the capabilities of XApp, RApp, and possibly add the apps and which are coming from the Open RAN community, and extend it to the transport and core network side as well, with the additional functionalities. And then on top of it, we have AI/ML management systems, which is distributed. So we are aiming to move from centralized management to more intelligent AI native management distributed structure with tuples that we propose to have monitoring system, analytical engine, decision engine, actuator that are distributed throughout the network to have this closed loop control and management with the AI native structure in the system. And last but not least, we have digital twin, which is virtualizing the network assets for better planning, network configuration, and to be able to make decisions in real time and for better integrated network planning and configuration management. So the main objective is to have this sustainable and scalable architecture, integrated AI native architecture that can support this diverse requirement of 6G. We also rely some of the technologies like distributed ledger technology for conflict resolutions between multiple domains and technologies, semantic communication for enhancing the efficiency in terms of cost and energy, and also for digital network, digital twin to enhance the performance. So the aim is to go from TRL 2 to TRL up to TRL 4 and 5 in the application and service domain. So we have 4 use cases that we are targeting. The first one is related to sustainable networks for disaster handling. This is the second one is immersive experience with real-time XR holographic communications. The third one is digital twin for integrated 6G network evaluation. And the last one is multi-RAT ORAN-enabled MPN for supporting time-sensitive applications for Industry 4.0. In addition to that, we have 2 experimental platforms. So POC is the main activity that we are also going to perform. 2 experiment platforms are going to be developed. One is going to be at CTTC in Barcelona, and the other one is going to be in IMEC premises in Ghent, Belgium. And then each of these POCs will involve different, actually, each of them has 3 experimental scenarios, which we are going to try to validate these technologies under these experimental platforms. So this is a more or less high-level picture of the work packages. So we have in work package 1 project administration and in work package 7 dissemination and standardization activities. So standardization activities will also be the main activity that we will target. So in addition to that, we have work package 8 as ethics dealing with the AI ethics domain. And then we have architecture and use cases work package, which is providing input to the 3 main work packages, which are technical. One of them is development. Work package 3 is developing of this open RAN transport and digital twin components. Work package 4 is more related to distributed AI driven intelligence. And work package 5 is providing these services and applications for the system. And then all these work packages are going to provide their components to the proof of concept that I mentioned previously, and we will try to integrate all these, I would say, enablers under the two proof of concept locations that we are going to work on. So I think that's all I wanted to mention briefly. So this is the list of the consortium logos, and thank you for your attention.